In this video, we're going to look at how to find the equation of the best fit regression line using an equation, using an actual formula. So we're not going to focus on the TI-84 and how to do it there, nor are we going to focus on how to do it in Excel. We actually want to show that we know the steps to figure out this equation. So the formula that we're going to use is y minus the average of y is equal to sx over sxy over sx squared times x minus the average of x. So in order to do this, we need to know what we're plugging in here. So y with the line over it, y bar, that means the average of y. And so does x bar. It means the average, but of course, of x. Sx is standard deviation of x, specifically. And Sxy is covariance. Now, I'm going to go on the assumption that you already know how to calculate all these values. And if you don't, you should definitely review the video before this one, the video on how to use Excel to find the correlation coefficient. So if you don't know how to calculate any of these values, you definitely need to look back at that video. All right, so now that we know how to calculate these values, we're going to pretend that we've already calculated them, because we have in a previous video, and we're going to write down the values that we got. So let's say we did these calculations and we got that the average of y is 4.21. So this was done in a previous video. If you didn't do it in the previous video, you can still follow. So let's say our average of y is 4.21, or average of x is 27.97, or standard deviation is of x is 3.76. Oops, 3.76. And or covariance is negative 2.15. Okay, so we have a bunch of stuff we need. And you'll probably notice that we don't have anything for x, nor do we have anything for y. And that's because there is a list of x values and a list of y values that we're going to use. Ultimately, when we finish this whole thing, it's going to be in the form y equals mx plus b. We're going to have a y in our equation and an x in our equation. So we're not plugging in y and we're not plugging in x, just the other stuff. Okay, so now looking back at that red formula, we're going to start plugging in. And we have y minus the average of y, which is right here. So y minus 4.21 equals sxy, which we have as negative 2.15, over sx squared, so 3.76 squared, times x minus the average of x, which is 27.97. So our first step was just to plug in these values, to plug in these four values. That's our first step. The next step, I would say, is to simplify that fraction. So we have y minus 4.21, I'm not changing anything there yet, equals negative 2.15, nothing there is changed, and now I'm going to square that 3.76. And when I square that 3.76, I get 14.14 approximately. Oh, and we're just going to keep everything else the same. So x minus 27.97. Now we can simplify the fraction further by dividing negative 2.15 by 14.14. And we get a value of negative 0.152. And I'm going to just keep everything else the same. And we have y minus 4.21 over here, the same. Now for our third step, we can distribute that negative 0.152. And we get negative 0.152x plus, because we have negative multiplied by a negative, 20, we're multiplying here, and I'm typing into my calculator, you can do it with me, plus 4.25 approximately. And we can keep the left side the same for now. So we're almost there. Again, remember we want it in this form, y equals mx plus b, but we have that 4.21 on the left side, so let's get rid of it. We would have to add that to both sides. And we get that y, I'll put it over here, is equal to negative 0.152x plus, and let's add that up, we have 4.25 plus 4.21, and we have plus 8.46. So now that is the equation of the line of best fit, the best fit regression line equation.